All right, y'all. So today we're going to be talking about end behavior, what's happening at the ends of the graph. We're going to be talking about extrema, which is just a fancy word for max and min, and how to just sketch a graph without having to actually plot 1,000 points and able to do so. Okay? All right. When we're talking about end behavior, the first thing we have to do is we have to look to the left and to the right to figure out what's happening on the ends, what's happening on the arrows of each graph. So what this is saying is, as x approaches infinity, which means as x goes out to the right, what is the graph doing? Okay, it's saying as x approaches, this is just another word that means approaches. As x goes towards positive infinity, what is the graph going towards? Okay? So as x is going out to the right, or as x is going out to the left, what is my graph doing? Is it going up? Is it approaching positive infinity? Or is it going down? Is it approaching negative infinity? That's all it's saying. Okay? So if we were going to look at this one right here, where we had to look at the end behavior from a graph. Now, sometimes it actually is a lot easier if you go in and you just draw the ends on both graphs so that you can clearly see where those arrows are going. Okay? Now, if we say as x approaches positive infinity, so as my x values go toward positive infinity, what are my y values going toward? Well, they're going up, so we would say they're approaching positive infinity also. Okay? Because they're going up. Now we look at it the other way. We say as x approaches negative infinity, so as x is going this way to the left, as it's going towards negative infinity, what's happening to my graph? Well, as we go out to the left, my graph is going down, down, down. So that means it is approaching negative infinity. So we would say that end is approaching negative infinity. Guys, it's all about the arrows. Which way are my arrows going? If my arrow's going down, then it's approaching negative infinity. If my arrow's going up, then it's approaching positive infinity. That's all there is to it. Okay? Now let's look at number 2. All right, number 2 right here. Okay, number 2, it's got arrows both pointing up. Okay? Arrows are both pointing up. Now, if my arrows are pointing up, we say that it's approaching positive infinity. So here we go. As my x values approach positive infinity, as my x values go out to the right, my graph is going up, 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 never stopping. My graph is approaching positive infinity because it's never going to stop going up. But then we can come back and we can go to the left. As x values approach negative infinity, I look at my graph over here. It's going up this time, so we're going to say it's also approaching positive infinity. It's okay. Sometimes these are going to be the same, and that's fine. That means we've got us an even function. When my arrows are going in opposite directions, that's when we've got an odd function. All right, taking a look at this one. First of all, I look at my arrows. I got one going up and one going down. So I already know I've got me an odd function because my arrows are going in opposite directions. Okay? Now, if I'm looking at it, as my x values go toward positive infinity, as my x values go toward positive infinity, what are my y values doing? Well, they're going down, down, down. So if my y values are going down, they're approaching negative infinity. But then if I go the other way, if I'm doing my x approaching negative infinity this way, to the left, my graph is actually going up. So that means that graph is approaching positive infinity. All right, number 4. Okay, in number 4, if I look at my arrows first, they're both pointing down. So if my arrows are going in the same direction, I know they're even. This is an even function. Okay, now I say, as my x values approach positive infinity, that means going out to the right side of this graph, what's happening to that graph? Well, it's falling down, and it's falling down quick. So we say it's approaching negative infinity. I'm sorry, going down, it's approaching negative infinity. Well, over here on my left-hand side, as I go out towards negative infinity, it's also going down real quickly. So since that one's going down also, it's also approaching negative infinity. And like we said, it's okay for them to be the same. The arrows are pointing the same direction, so it makes sense that these should be the same. Okay, now sometimes they're not going to give us the graph. All they're going to do is give us the equation. And we have to use what we know about even and odd functions in order to kind of visualize how that graph is going to look. So like in number 5, if I look at my degree is 4, which means it's even. And in the video that we just did, in the practice problems that we just did, we said that all even functions are going to have their ends going in the same direction. If it's a positive coefficient, then both ends are going to be going up. If there's a negative coefficient, then both ends are going down. Well, if we look at this one, this is like an imaginary 1. It's positive, so I know that both ends of this graph are going to be going up. And if they're both going up, that means that as it approaches positive infinity, going up means it's also approaching positive infinity. Because remember, if both ends are pointing up, I don't care what this graph looks like. As long as both ends are pointing up, they're both approaching positive infinity. So that's just kind of a shortcut where you don't have to write everything that you see. Okay, let's look at number 6. Looking at number 6, I look at my degree. My degree is 5. 5 is an odd number. And we know that for odd functions, my arrows are going to be going in opposite directions. Okay. Now, if it is a positive coefficient, then my graph is climbing from left to right. If there is a negative coefficient, then my graph is falling from left to right. Now this coefficient is a -1, so I know that my graph's going to be looking kind of like this. So no matter what's going on in the middle, on the left-hand side, it's going to be going up, and on the right-hand side, it's going to be going down. So to describe that end behavior, as x approaches positive infinity, as we go towards positive infinity, my arrow for that one is going down, so it's approaching negative infinity. And then as x approaches negative infinity, as x approaches negative infinity, as it goes out to the left, I look at my arrow, it's going up, so that means it's approaching positive infinity. Okay, we got us one more. I bet you've got it by now. Okay, looking at my degree. Degree is 3. It's odd, so I know it's going to be going in opposite directions. So now I look at my coefficient. My coefficient is a positive 2. So since it's positive, that means my graph, it's going to be going in opposite directions and it's going to be climbing. So in some shape or form, it's going to look like this. So as I go to the right, as I go out to the right, my graph, as I go to the right, my arrow is going straight up in the air. It's approaching positive infinity. But as I go down to the left, it's actually approaching negative infinity because it's falling down. Okay, sometimes they're not going to give us anything but a picture. And we have to say what we know about this graph just based on what we see with the end behaviors. Well, I see I've got one arrow that's pointing down and one arrow that's pointing up. So I know right away if they're going in opposite directions, then I know it's got to be what kind of function? It's got to be an odd function. It's got to have an odd exponent. Now it's climbing as I go from left to right. It's climbing. So since it's climbing, then I know that my leading coefficient is going to be positive. Checking out another one. If I look at the arrows on this one, I've got an arrow pointing down and an arrow pointing down. They're both pointing down in the same direction. So since they're going in the same direction, first thing I know is they must be even. Now if they're both pointing down, if they're both going to negative infinity, then I know that leading coefficient, if it's flipping that graph over, then I know that my leading coefficient must be negative because it flips the whole graph over. Okay, checking out this one. If I look at the end behavior on the left, I've got one arrow going down. I've got one arrow going up. Okay, arrows going in opposite direction. Odd is opposite. And then I have to say, well, is it a positive coefficient or a leading coefficient? Even though my graph is kind of crazy, going up and down and up and down and up and down and up, since it ends up going up, since the very end it's approaching positive infinity, it's increasing, then we're going to say it's got a positive leading coefficient. So that graph, it is an odd exponent, but it also has a positive leading coefficient. Okay. Now, my extrema, like we talked about yesterday, we were talking about maximums and minimums. Okay, so if we're looking at it, my extrema are how many times that graph turns. how many times that graph changes direction. Okay? So if you're given a graph, what you do is you count the terms and then you add 1 to get the least possible degree of the polynomial. For example, if we look right here, if we're given this one, if we're given the function, then we take the degree and we subtract 1 to get the extrema. So looking at this one right here, looking at the first one, okay, it says if you're given the graph, then you count the number of turns. Okay, so it goes down. Here's 1 turn. Here's 2 turns. Here's 3 turns. That graph has 3 times that it changes direction. Okay? It says count those number of turns, and then it says add 1 to it to get the least possible degree of this polynomial. So for this one, since it's got 3 terms, we would say that it must be a 4th degree because it says 3 plus 1. That means it's going to be a 4th degree. It's quartic. But my number of extrema, my number of turns is 3. So when you're given a graph, what you do is you count the number of turns that you've got, add 1 to it, and then you know the degree of that graph. Now, if we don't have a picture, if we just have an equation, then we need to use our second rule. It says if we're given that function, take the degree, which means your biggest exponent, take your degree and subtract 1 to get the extrema, to get the number of terms. Okay, so we know that the degree of this one is 3. Now, if I say 3 minus 1, well, 3 minus 1 is 2. So that means that this graph, even without us drawing it, is going to have 2 turns. It's going to have 2 places where it changes directions. 3rd degree, 2 extrema, 2 turns. So if you're looking at this one, number 8, what is the least possible degree? Now we're given a graph. So remember, when we have the graph, if we want to find the degree, to go from the graph to the degree, that means we just need to count the turns. And then after we count the turns, we need to add 1 to it. Okay? So my turns on this graph, it's going along right here. It starts to change direction. There's 1 turn. Then it's going along. It hits the bottom down here. There's your 2nd turn. This one has 2 turns on that graph. So 2 plus 1 gives me 3rd degree. Which means you've got a cubic polynomial. 3rd degree. All right, my next one. Looking at this one. What is the least possible degree of this function? Remember, I count my number of terms. 1, 2, 3. So I have 3 terms. And then I add 1. So that means my degree is 4. Now, if you had to look at it and you had to tell me something about that end behavior, they're both pointing down. So you know it's even, so that makes sense. What could you tell me about the coefficient if they're both approaching negative infinity? My leading coefficient must be negative. So what was the least possible degree of that graph? It had 3 terms. 3 terms plus 1 gives me the 4th degree. Okay? What if we just flat did not have a graph? and we had to find the extrema. Well, remember, our other rule said take our degree. So my degree is 4. And if I subtract 1, that means that I'm going to have 3 turns in that graph. And you know, turns is just another word for extrema. So that graph's going to have 3 extrema. Looking at number 11, my degree is 5. So 5 subtract 1 means I'm going to have 4 turns in that graph, which means I'm going to have 4 extrema. And then lastly, number 12, my degree, my biggest exponent is 3. So I just say 3 minus 1 gives me 2 turns. So 2 turns in that graph means I have 2 extrema. All right. So if we had to just sketch a graph, let's say you didn't have a calculator and you needed to sketch a graph. The first thing it says, I am given the zeros are -10 and +2. So I know I'm going to have a 0 at +2 and 1 at -10. So it's going to be down here somewhere. Okay. I can also look at it and I can say, all right, this is an even function. It's even, so I know that both ends are going to be doing what? I know both ends are going to be going up. Okay? So for my number of zeros right here, my number of zeros, it told me that. It gave me 2 zeros. Okay? So I was given 2 zeros. If I had to find my y-intercept, remember your y-intercept is going to be on your y-axis. And no matter where you are on that y-axis, your x value is going to be 0 because it's at the origin. Okay? So if you plugged in 0 into this equation, 0 squared plus 8 times 0 minus 20, well, that's 0. That's 0. So my y-intercept is at the point 0, -20. So I know my y-intercept is going to be way on the map. Now we just said that it's even. My leading coefficient is a +1, so I know both of my arrows have to be going up. So as x approaches positive infinity, my graph is going to be increasing. It's going to be approaching positive infinity also. As x approaches negative infinity, it's still going up. So it's approaching negative infinity. Positive infinity. Goodness gracious, I'm reading the wrong thing. All right. So now I've got to talk about my extrema. Well, extrema, remember, that's when we just say my degree, which is 2, my degree minus 1 leaves me with just 1 turn, or 1 extrema. So my graph is going to look something kind of like that. I know this is ugly, ugly, ugly. We don't even have any numbers. But that's what sketching's all about. It's not exact. It's just so that you can get the general idea. Okay, number 14. This is our last one, y'all. Okay, my number of zeros. Given zeros, 1, 2, 3. It gave me 3 zeros. So my number of zeros is 3. My y-intercept is what I get when x is equal to 0. So if I put x equals 0 here, well, 0 to the third is 0, plus 0 squared is 0 times 2 is another 0, minus 0, so 0, 0, 0, minus 2, so my y-intercept is at negative 2. It's at the point where x is 0, y is negative 2. Now, if I look at my degree is odd this time. So we know that if it's odd, then they're going to be going in opposite directions. Okay, now which direction it's going has to do with my leading coefficient. Well, my leading coefficient is a positive 1, so I know that my graph is going to be climbing as I go from left to right. So as my x approaches positive infinity, as my x's go out to the right, my graph is going to positive infinity. As my x's go to the left, my graph is falling down, and it's going towards negative infinity. Now my number of extrema, all we say is my degree was 3. Subtract 1. So that means 3 minus 1 means I've got 2 terms or 2 extrema. So now, using your notes, oh yeah, I'm sorry. This is one of our ugly little sketches. But you can see it's got 3 zeros. 3 zeros. It's got a y-intercept at negative 2. Its end behavior matches what we expected, and it also has 2 turns, turn 1, turn 2. Okay, so now, since you know how to do everything, I want you to go ahead and start working on your homework worksheet. If you do not finish it and turn it in today, it is due tomorrow.